I'm Mike Downen.
Yeah.
Are we rolling here?
Yeah, just look at
okay.
me or look at him. Or
Yeah, just say don't look at the camera.
Don't look at the camera.
So, who are you?
I don't know. I don't know anymore. I'm Charles, Channel 9, and you are Mike Downen.
I'm Mike Downen, CLR security team. So the CLR security team owns...
Let me get on the other side of you, because the window here is nice and
backlighting.
bright.
Yeah.
Oh, yeah. Much better.
Okay.
I can actually see your face now.
Cool. So the CLR security team owns a bunch of stuff in the CLR. We own code access security, both enforcement and policy. We also own cryptography, so a bunch of the crypto APIs, and then we own kind of some of the other other odds and ends in the virtual machine, like the app domain manager, some of the stuff associated with managed hosting, that sort of thing. Kind of our big goals for WIDBE, we're making it simpler and easier to develop and deploy secure apps. So we did a lot of work in kind of to support the click once deployment model. I know you guys have done some features on that.
Yeah.
And added a bunch of new crypto stuff to make developing crypto aware applications easier. And then just trying to simplify policy. It's a big kind of stumbling block for people to deploy CAS policies throughout an enterprise now. So
Cool.
that's our focus for this release and for upcoming releases as well.
Fantastic. Excellent. And we're going to go meet the team.
We're going to meet the entire security team.
Wow.
So are we ready?
Yeah.
And,
Let's take us around.
wander out, and we'll talk to our architect, Charlie Kaufman. He started with the team a couple of years ago. He's written a textbook on network security, so he's kind of a mini celebrity in security. Right here, sure. We're kind of spread out all over Building 42 here. Being the security team, we like to keep tabs on what's going on everywhere.
So security person on every corner.
Yeah, exactly. Throughout the building.
So what else?
Scoble gets exercise.
Yeah, this is geek exercise here. Walking backwards.
Hey, Charlie. So this is Charlie Kaufman, our architect.
Hey, how are you doing?
And Charlie, so tell us, how long have you been with Microsoft, Charlie?
I guess about 1.5 years.
Oh, awesome.
And before that, what did you do?
I was the security architect for Lotus Notes.
Okay.
Wow.
And you've written, I think the network security book is over on the bookshelf here.
Show off my book here.
One of the standards. Charlie gets his pitch in here for.
So you know Ray Ozzie then, right?
Oh yeah, I worked with him a lot.
Okay.
So
The Lotus Notes guys are taking us over.
Yeah, cool. Okay.
So watch which competitors you start beating up on.
So and we'll go ahead.
So what do you do here? You're an architect?
Yeah, I'm the architect for CLR security.
Okay.
And so it's figuring out where the hard problems lie and what we need to do about them and stuff like that.
What does it mean to make a secure runtime system like the CLR?
Yeah, well, kind of an interesting question. Something we think about is how CLR security fits in with OS security, for example.
Okay.
That's often an area of confusion. So I know Charlie was just thinking about that.
Right. One of the challenges that we recently faced is with the Lua effort in Longhorn and how to make sure that our stuff integrates well with that and how to answer the question, well, how do these relate? Do I need one or the other? Do I use both? And how do they fit?
Right. Lua is for people.
Least user access, I think.
Yeah.
Right. And essentially what it is, it's not really that different from what was available in the past. What we've been encouraging people to do ever since Windows 2000 is that most users should log into accounts that are not administrators. And the advantage of that is that if you're logged into an account that's not an administrator and you run a program that goes haywire or is malicious or something like that, there's a limit as to how much it can do on your machine. And so it's a way of protecting things. Unfortunately, we haven't had very good luck at convincing users to do that. It's a bit of a chicken and egg problem. People don't want to take admin off their accounts because it breaks certain apps, and nobody wants to fix the apps because all the users are admin anyway, so why should I go to the work? Yeah. And so the new step in Longhorn is that even if the account is admin, most applications will run only with the less privileged user rights, which will sort of be another nudge of the applications in the direction of they need to support this, because there'll actually be extra steps they'll have to go through if they actually need the admin rights to be able to work.
Now, where do programmers go wrong? In other words, where do apps stop working? What do developers need to do differently for the Lua world where they weren't doing it in the admin world? What are the top 5 or 10 things that they have to worry about?
The main thing is thinking about where it is that they're going to put their files when they put things. That there are certain directories that are common to the machine and are not modifiable by ordinary users. So when you install your application, you need to clearly separate the stuff that gets put in there for the install that ought to be shared and the stuff that the user might need to be able to update later, such as all of his configuration information, all the files that he puts there. And so there's sort of well-known ways to do that, but people got into the habit of not doing that back in the dark ages, and it's a matter of converting the applications around. But the more interesting question from my perspective is, how does this fit with what we're doing with code access security in CLR? And while you can think of admin as having full run of someone's computer, Lua is sort of a subset of that. It's a little protected box that the amount of damage that somebody can do with Lua rights is limited, but still substantial. In particular, it can get at all the user's files and anything that the user can normally do.
So send your money files off to some FTP server halfway across the world. Still
Right.
a bad thing to happen.
Right, it can still read all your email, delete all your email, all that kind of thing. The only thing it can't do is install things on the machine that are then going to run in the background in order to catch things later. Mm-hmm. So what CLR is primarily used for is to implement a much smaller sandbox, which is the set of limited rights that web pages, the script that you download on web pages typically runs in, which is very limited. When you can download something off the web that will put up a form and you fill it out and it can communicate back to the site that it came from, but it can't access any of your files normally, and it can't go out and talk to other sites. And so essentially CLR is used to implement that sort of sandbox so that people can write powerful applications that nevertheless run safely, and the user doesn't have to think about running. They just get downloaded and the user can run it.
Right.
So essentially there's a separate internet zone sandbox created for every website that you visit, as opposed to the Lua, where there's usually only one on a computer. There's one per user, and most computers only have one user. I guess home machines you might set up several. Okay. But here there's going to be one per website. They're all kept separate from each other. So you can think of it as a sandbox within a sandbox, where Lua is the bigger one and the CLR implements the smaller one.
Got it.
Some of the challenges that we faced are things like click once applications. Click once application install is one of the things that we're supporting. And that it's very important that work in the Lua environment. In other words, it was important that those applications not require admin rights to be able to install and run. Mm-hmm. And we have set it up that way. It means that certain optimizations can't be done. If you have multiple users on a machine and they all want to use the same application downloaded, be it click once, they each install their own copy. Okay. But the fact that they do that allows the users to be kept separate. It means that you don't need any high privileges on the machine in order to be able to run all these things. Mm-hmm. And so it's an important integration point. Over time, I expect that there'll be multiple more layers of sandboxes within sandboxes. Ultimately, you'd like to run everything with the lowest level of privilege that it needs to get its job done. Yeah. And so we'd like to be able to create guest accounts on machines. If I'm going to run a game program, I'd like it to run it in a way that the game program can't access my money files or other things like that, and that the system just sets everything up to protect things the way you'd like.
Right. When you harden a system and make it harder to attack, which is what Lua is going to do, mm-hmm. The bad guys go elsewhere. In 5 years, if we came back to you, where do you think the new threats are going to come from? And what do developers and users now need to think about to develop an app that's even more secure going forward?
Well, the bad guys are very adaptive, and they'll essentially go after, whatever the weakest link is in the system. One of the things that's popular right now is these phishing attacks, where somebody will send you an email message with what looks like a link to some site that you use all the time. You click on it, it looks like the site, and they trick you into entering your username and password, and then they can impersonate you.
So the human is the weak link in the chain.
The human is always the weak link in the chain, and really what the technology does is make it easier for the user to do the right thing and harder for the user to do the wrong thing. The user is always going to take the simplest path, and we want to make it so the simplest path is also the most secure one. That it will always be possible for someone to say, well, to do this, what you're going to have to do is go through these steps. First, log in as administrator, and then type, delete all, and, stuff like that. And if you can get the user to follow your steps precisely enough, you can always, get the user to mess things up. But we ought to be able to make it so that that doing something like that looks very different from what users do in their ordinary life.
Okay. Now, one of the problems, an interesting problem, was that the Office team had, or at least we interviewed and talked to Eric Lippert, who told us about their security plan, because now you can actually get a document that runs code.
Yes.
And so they had to do a lot of work with you guys, obviously. So do you scan assemblies to see what it's going to probably do? So, for example, this assembly is using system.io. Let the user know, or it's using something that could be dangerous. I mean, you can scan now easily.
Yeah,
with
we don't do that sort of scanning. We do have this what we call verification or IL validation step. So when you load an assembly, we look at the metadata and we look at the IL code in the assembly to make sure that it's verifiable. So it's doing a safe subset of operations. It doesn't run past the end of array boundaries. It doesn't reference memory in non-type safe ways. This is kind of like the cornerstone of CLR security in that it, if you don't do this, then we could just read random memory in the process. You could easily escape the sandbox.
Now, what happens when you have an application that's, say, written in managed C++, and I'm doing a lot of unmanaged stuff for whatever reason,
Right.
and then I have my managed stuff? How do you deal with verifiability? Obviously, one's unverifiable.
Right. Yeah. I mean, you certainly have code that's not verifiable, and running unverifiable code is a privileged operation. It's a high-level permission, so that would have to be highly trusted code to execute on unverifiable code. Cool.
Right. You were talking about, can you scan it and tell what the application does? What we can do, and this occurs in click once, is the application ships with a manifest in which it declares all of the things that it intends to do.
Okay.
And then there's a runtime enforcement that if it tries to do anything that wasn't in that list, the program will be stopped at runtime. And so the user, essentially the system will go over the list of what it wants to do, and if all the things that it wants to do are considered safe, then it will just run the program without any security warning to the user. If it's not, then the user will be informed as to what the thing's trying to do, and the user gets to make a decision. And there are lots of inputs we can make to that. We allow content to be digitally signed, and then a user can say, well, I want to trust everything that comes from my corporate IT department, and then so then the program can run again, either without a warning or the user gets informed as to where it came from in order to make an intelligent decision in that regard. Otherwise, but in all cases, the user has the choice of what it is that they want to be able to do. One of the realities of security is that in order to really be secure, you have to make sure your system is designed so that it doesn't put up these warnings all the time. You might think that a way to make a system secure is every time it's going to do something dangerous, you put up a warning. But if it puts up warnings too often, users just get in the habit of saying, okay, and always clicking, don't ask me this again. So what you really need is to not only put up security warnings when something dangerous is going to happen, but make sure your filters are designed so that you don't put up those warnings when something safe is going on, so that users don't get false warnings, so that users can actually be trained to always say no to those things unless they know that something special is going on.
Right.
Like writing to a file or reading from system information, etc.
Right.
I mean, I'm just reiterating.
Okay. How did you get into security?
I actually got into security back in the 70s. I worked on one of the most secure time-sharing systems in practice that was ever built. It was called Dartmouth Time Sharing System, and I got my start by breaking into it. And I was the last one to successfully do that because I also designed the fix to how to keep people from doing it again. And I've always find it's sort of more challenging to be on the good guy side because you have to think of more possible. You have to think of all the ways to get in, whereas to be a bad guy, you only have to think of one. Right. And so, I've always found that to be, a really neat place to work, and it's always been of interest to me.
How is Microsoft's approach to security? Since you're new here and you've been able to look around at our products and our teams here, how would you evaluate Microsoft's approach?
Well, Microsoft.
Because we haven't had the best of
Microsoft's security reputation is not all that we'd like it to be. I was quite surprised when I got here at the tremendous amount of effort that Microsoft is putting into security in terms of the reviews and the audits, and because most people out in the world would not have guessed that. We come to the problem with a very big backlog that there were years of development and we have to maintain backwards compatibility with it. Mm-hmm. So there's all kinds of things to plug, but we're actually working at a great pace to tighten things up. And I think that the systems that we're shipping today are actually very, very secure. We also suffer from our own success, and that because it's the most widely deployed system, it's the system that people tend to attack the most. So it's I wouldn't want to say that we're doing a great job and we can afford to slack off. But I would say that we're definitely headed in the right direction and giving it the kind of attention that it deserves.
Right, absolutely. And this is an industry problem, right? It's not a Microsoft, because there's. If you read Slashdot, you see other products out there have attacks and vulnerabilities. How do you feel about the school system? Are new hires who are coming into the computer science world, are they being trained enough on how to build secure systems?
The education system is probably not all that it should be about training people to do security. On the other hand, just as I said that users will always do what's easiest and you better make it secure, people that are developing graphics applications shouldn't need to worry about security. And so, in fact, one of the things that's important is that we build the tools so that it's easier to build a secure application than an insecure application. Mm-hmm. And that's one of the things that's going on. That with .NET. All of the subscript checking and type safety checking is done automatically, as opposed to when you're writing in C, and it's a lot easier to make those kind of mistakes. Yeah. Likewise, other sorts of things that are doing in layering, to the extent that we put Lua in the operating system and internet sandboxing in CLR, it again means that the programmers don't have to worry about it as much, and if they don't have to think about it, then they won't get it wrong.
Precisely.
Well, thanks for spending some time with us.
Yeah, thanks, Charlie.
Okay.
We're gonna
Great job.
wander off and meet one of our testers.
Cool. Now, is this a hacker tester?
No, not so much. This is more kind of a traditional feature tester.
Okay.
Testing all of the code we own, that sort of thing. So,
right. Where are we going?
We're going. We'll go straight. We'll hook a right all the ways down the hall here.
Okay.
So, as I said, we're spread out. We want to keep people everywhere. We'll make the trip across the hall the other side of the building soon as well.
Cool.
Yeah. So interesting, points Charlie made. Kind of the differentiation between Windows security and CLR security on this way. We're more focused on this code access security sandbox, this kind of internet zone enabling technology to keep you safe, when you're browsing the internet, to allow other hosts, SQL Server, for example, with their next version, you can write stored procedures and manage code, and they use code access security. Not just to limit what those can do from a security point of view, but also from a reliability point of view. You don't want stored procedures popping up dialog box.
Sure.
Cool. This is Sean. Sean's a tester on our team. Cool. And a big Jets fan, as you can see. So, celebrating the signing of law, I guess. So, So Sean is also a big guy in the community. He has a very popular .NET security blog, so I'm sure there are people out here who are happy to see the celebrity Sean here.
Cool.
So tell us what you work on, Sean.
Mostly I work on crypto, IL verification, click once stuff, and various infrastructure underneath.
How long have you been at Microsoft?
3 years last week.
And you started in this team, right?
Yeah, I interned here and then I came back full-time security team.
Very cool. So we were just talking to Charlie a little bit about the difference between Windows security and CLR security, and kind of Lua and CAS sandboxing. And I know you've worked on Click Once, and we've added some new APIs to make sandboxing simpler. So talk about that a little bit, your experience with that stuff.
So what we did is when you sandbox in an app domain, it's sort of you create an app domain with less trust than the rest of the application. You might want to be hosting some untrusted codes, third-party add-ins or whatnot. And with V10, V11, you had to set up a new app domain. You had to create app domain policy, which involved creating a whole hierarchy of code groups and different membership conditions. And it was a real pain. It was tons of code, and you probably get it wrong on occasion, which could end up having more trust for your untrusted add-ins. So what we did is we added new APIs, which Click Once takes advantage of, and also we've exposed it to the users, where you can just specify the permission set you want. Right? You do app domain, create domain. Here's the permissions. Here's a list of full trust assemblies, because you probably want your app to be full trust still. And we give full trust to assemblies in the GAC, we give full trust to assemblies on your list. Everybody else just gets that permission set. We made it nice and easy for everybody to do that. Obviously, that's the model within Click Once, where you specify my application needs these permissions underneath the covers. We use the same system to hook that up.
Right. Sweet. And that's kind of a theme we had for WIDBE, and a general theme for security is that complexity is the enemy of a secure system. The sandboxing stuff was very complex, hard to get right. Sean had to write tons of blog posts on it, which keeps him busy, but isn't the best for security. So our big focus was to make that simpler, and something we're going to be investing in more going forward.
Yeah.
So
Sounds great.
Since you're a tester, what's your mentality, and how is it different from other people on the team? What makes a good tester is maybe a good question. Or how do you attack systems to make sure that there aren't bugs going out that could open up holes in the product?
So sort of what we do is since CLR, kind of expose a lot of programmatic access to things. So with this API in specific, I kind of helped design it along the way. And as you look at all the parameters, like, all right, well, this is how everyone's going to use it, right? But if I'm not going to use it the way we're expecting to use it, what if I, try to force an assembly into full trust list that I have, right? What if I create a new app domain, even though I'm in a partially trusted one, can I force that? And basically just kind of going through the APIs and saying, this isn't what it was designed to do, but if I force through, can I make it do something different?
That's a great point, because that's like basically the way hackers will work.
Right.
I mean, it's entirely what you do. You stretch something, you do something, you take advantage of something by doing something that it wasn't designed to do.
Exactly, yeah.
And you find a flaw.
Right.
And that's what you do.
And on the other end of things, we also, part of this making things easier, we don't want to make the API so complex that to use it correctly, it's going to take, you got to work here at Microsoft and talk with us. We want everyone to be able to do it properly, where like the old APIs, I said, you have to set up a ton of stuff, you might get that wrong, and now all of a sudden you've exposed your application as a new attack vector.
Right. Code access security was hard, as you're saying in VO 1.1 also. Glad you guys have made it easier.
it's still too hard, but we are working on making it easier.
It's a hard problem.
Yeah. Security is never going to be completely simple, especially for developers.
Since you're pretty familiar with the system, probably more than any other person in the world, what would you tell another developer to check out that you think the team did particularly well? Or
In WIDBE, I think we did a great job on hosting, where we made it, well, obviously hosting is more of an advanced application, but we made it a lot easier for a host to specify exactly what they want the application to be able to do, and to have a lot more control over what's going on within their own application. Whereas in V11, it was, a host had a lot of control, but not necessarily as much as they would need to be completely secure. Whereas, with SQL Server hosting with us, we had to do a lot of work to make sure that this worked properly, and so I think we did a nice job with that.
Excellent.
any other questions?
Sounds
Thanks for spending some
Thanks,
time.
Sean.
Thanks.
We're gonna
Go Jets, huh?
gonna wander down the hall a little bit here and talk with another one of our testers, Guillermo, and kind of shifting gears a little bit to talk more about some of the crypto stuff. Hey, Guillermo.
Crypto stuff.
Crypto, yeah. Cryptic crypto. So,
Can you turn on lights?
yeah.
Excellent.
So, it's Guillermo.
hey, how
Nice
you
to
doing?
meet you on our
Yeah,
test
man.
team.
We're Channel 9.
Yep.
Yeah, and Robert.
Familiar with you guys?
Yeah.
Familiar with Robert?
Probably
So it's
swearing
like
down
he's a
me.
celebrity.
What the hell did he write on his blog today?
So yeah, Guillermo works. Tell us what you work on. And
So,
test.
I work in the CLR security test team. I own the execution context, X509 features, perm calc, transparency, security transparency, among other minor features. So it's
When
kind
you say
of.
security transparency, what do you mean?
So when Whidbey, we're introducing a new concept where you have critical code and you have transparent code. And critical code is the code you're writing in Everett and RTM. You can do everything that you can do now. Transparent code kind of pairs back what your code can do. So for instance, transparent code is unable to assert. If you have a CAS permission assert, it'll throw an invalid operation exception. So there's kind of pillars of what transparent code does. It's unable to satisfy a link demand. Let me turn this off too.
All right, thanks.
So yeah, the
Pink Floyd going on.
Excellent.
Transparent. It's unable to satisfy link demand. So, say for example, a transparent method calls any kind of method with a link demand on it. That link demand becomes a full demand.
we'll talk a little bit more with our dev lead Raja, who kind
Sure.
of architected the
Yeah.
transparency feature. It's another one of these kind of in that column of making CAS easier to secure properly.
Yeah.
In previous versions, basically any code you had could elevate privilege, could do asserts, could do potentially dangerous operations, and then expose that to untrusted callers kind of unwittingly. Kind of in the interest of running code in least privilege, we've added this transparency feature that makes it, now you have to mark code that you intend to elevate privilege as security critical code. And then the security transparent code pretty much runs with the privileges of its caller. So if it's called by low trust code, it can't do a whole lot. It can't satisfy link demands, that sort of thing. If it's called with high trust code, then it can do whatever.
So
the
should
high trust
you ever really assert though and ship in code? I mean,
The only time these are code access security asserts. These are different than kind of debug asserts.
Okay, that's
so
what
it's
it
a
said.
different concept.
Thanks.
Yeah.
Well, I heard that. I was like,
That's it's an unfortunate choice of terms back
Totally.
in 1.0 because
Okay.
we hear that confusion. So
excellent. So what do you like? So are you writing apps to try to break the model, or like?
Yeah, so typically in the transparency testing, write apps kind of hitting these scenarios. For example, I'll write an app that has a whole bunch of different link demands, identity permissions, CAS permissions, custom permissions, and then a simple test case will be to call those methods with a link demand and make sure that a full demand bottles up. So I'll have a degree of a stack on there that that's so many levels deep, and then I'll have some other CAS modifier such as a permit only or a deny, so that I know that demand bubbled up and hit that, and I throw an exception, and then I evaluate the exception, make sure that what was thrown is the right thing that was thrown. That's kind of, for every area you test, you kind of test differently. It seems like there's there's 3 different methods to test. For something like transparency or execution context, it's really a infrastructure-based testing, so it's a bit more end-to-end and interesting corner cases versus something like the X509 classes, which are .NET Frameworks APIs that require a degree of making sure that the input you put in gives you the right it's more of a state-based testing. So if I have a X509 store, I add a certificate to it. I just need to make sure that the certificate's in there via verification is to use the same class to make sure the certificate's in there. An interesting bug that was found though in pre-beta 1 times was that on certain platforms the certificate would be added in there and the class would say the certificate gets returned back, but when we looked at it in the registry, the certificate was really in the wrong location. So, then that required adding another level of verification, such as the actual registry verification to make sure the certificates in the local machine or current user context.
Cool. Cool. That's quite a hat, by the way.
Yeah.
Nice job. Man. Cool. Well, excellent. And those are all the products you've worked on?
Yeah,
those are a lot of stuff here.
Well, I didn't work on Fox Pro 6, but I was an intern in 1999, and that was my parting gift.
Excellent.
Also, some MSN. That's the MSN 8 Gold CD. After we shipped MSN 8.
We get the nice Ship It awards and the trophies for...
Yeah, we get ship-its, the clock,
the
5-year
clock.
5-year clock.
Yeah, I got the pen.
You picked the pen, not the
I thought
clock?
the pen was going to be a lot nicer than it was. I'm very, very disappointed in the pen.
We'll have to go to ask Bill about that.
Yeah. What's up with that pen, Bill? I always lose my pen, so I figured it'd be a lot harder to lose the clock than the pen.
Yeah.
Good choice. I went for
Right
the
on.
clock, too.
Well, great to
Well,
meet
cool,
you.
thanks.
Likewise. Thanks a lot.
All right, now we're going to wander across the building and
Let me see through here.
meet our dev team. So there are a couple members of our test team.
Cool. Now we meet the devs.
Yep, meet the devs. And we'll start off with Raja, who's our dev lead, and he'll talk a little bit more about the transparency feature and kind of what we were going for there. That's good. As I said, we like to stay spread out, keep our tabs, and it's good to get up and get some exercise.
Totally.
Since the majority of our job is sitting on our butt writing emails. So,
Yeah, it'd be nice if they could have, you could write code and run.
Yeah, exactly.
You know what I mean? Run
A
around.
tablet PC with a harness or something.
Yeah.
Product idea for the next version. So you guys met with the BCL team a
We've
few
met
months
with
ago.
Yeah, we've done so much CLR. It's amazing.
Oh yeah, they like to. They're all in this hallway over here. They like to stay very tightly focused. We like to spread out a little bit.
Sure. Well, you're security.
Exactly.
You're everywhere.
Yep.
Security is everywhere.
Yep.
What's the fun part about working with the CLR team?
The fun part with working, I think the fact that it's used everywhere. I mean, it is just the we think of it as the managed kernel. So everybody's using it. Exchange, SQL. It's a lot of fun. It's very rewarding in that respect. So.
All right, now why do all the devs always have dark offices?
Yeah, these guys, they don't like to be seen. Only get the lights. They're vampires.
I've never gotten a good answer.
No,
though.
the window will backlight.
Yeah. Actually, let me just get behind you over there.
So this is Raj. Raj is a dev lead for the security team. So why don't you talk about what that involves, Raj?
Well, I've been in CLR for about 7 years.
Since the beginning.
Since the beginning of version 1. I've been in Microsoft 10 years. So in version 1, I worked mostly on all the comm interop and managed remoting, interop, and decom kind of stuff. For Whitby, I took ownership of the security team. So my team owns code access security and all the crypto services. So let me talk a little bit about code access security, I guess. For Whitby, we focused on making the model easier to use for different developers. There are developers that are building apps, and there are developers that are hosting sandbox code, and then there are developers who are trying to build what we call as APCA libraries to provide services to partial trust.
We had a pretty good discussion of sandboxing with Sean and Charlie, and kind of the whole transparency topic came up. And I know Raja kind of architected that. He's got a slide here. Look at this.
We don't let slides on Channel 9.
No, it's just to show.
Wait a second. Wait a minute. You prepared for this?
Yeah,
All right, let's go.
I just showed the slide.
In the interest of full disclosure, Raja did do a short stint as a PM. Currently on display.
I think one of the things that we are trying to do is get people to understand CAS better. It's people are used to a V1 CAS model where we had assembly level security. So it's been pretty tough trying to get people to say think of the simpler model that we are exposing. That's why I keep having the slide. I show it to everyone. Whoever thinks about CAS saying, see this picture, right?
Well, since you have some code up there, can we talk about
Sure.
Give us an example of code access security today. How easy is it to?
So there are different levels, right? Let me taltalk about one part of it, which is APCA libraries. So one of the things is we want to make sure the sandbox is rich. We want people to build a lot of new services to a
Just as
sandbox, right?
when we say APCA libraries, we basically mean libraries that expose functionality to partial trust. So
Okay.
the BCL, for example, exposes access to files to partial trust. So it'll do the proper security checks before allowing you to access a file.
So if you download an app from the internet, right, what are the safe things you can allow it to do? So there are people, the framework is a good example. When WinFX comes out, Avalon would be another good example where they're trying to provide a set of functionality so that like any untrusted app can call into that functionality, make use of that functionality without compromising security.
Fantastic.
But it's not pretty straightforward. If you want to build like a service that's going to be exposed to untrusted code, you really have to be very careful as to like how you implement the functionality. Such libraries are usually marked with a special attribute called allow partially trusted callers.
Okay.
Right, so to even
And-
do that, you have to opt in. So
Yeah.
your typical developer who doesn't care about doing that, that whole scenario, they're not adding any security risk. You have to specifically opt into this to do it.
I started prototyping some simple examples. So let's think of somebody who's building some library like this, right? I mean, I just put like one really simple example here. When he's writing code, he has a class here, which is a sealed class. I'm calling a transparent class as an example. And there's a method called execute code. And he basically says, hey, I'm going to create a delegate on top of this add memory pressure method, and then call it. So what he probably doesn't know is like this add memory pressure, that API has a link demand saying only trusted guys should be calling it.
Good.
But then this guy is trying to build a service on top of that, and because he's going to be like a fully trusted person, like this
part of
code
it,
is going to be
And
fully.
this brings up an excellent point, because this is like one of the exceptions, or a good example of when you're trying to use somebody else's code. Not being able to know what type of exceptions they're going to throw often
Right.
leads developers to do things like catch exception, which is a disaster.
Yes.
So how do I know that system.gc, that add memory pressure, demands full trust just by using the library? Is there any way that I can get that information? Do I have to use reflection to figure that out?
You can look at MSDN.
Yeah, it's basically documentation.
That's what I'm saying. But I mean, when you create an API, why can't you? There's no way for you to expose to people what kind of trust you require.
The API does have. You can use reflection to find it, and we
Okay.
have a tool that actually
Right.
shows
Yeah,
what
yeah.
permissions are needed.
There is a tool.
There is a tool that will tell you, like if you talk, the Visual Studio has even IntelliSense that will tell you, if you call that API, this API requires.
Yeah.
Beautiful.
Right.
Just an orthogonal
Right.
topic.
Right.
Okay.
But that's for app developers, right? For a guy who's building a library, if there's a link demand, he's going to satisfy it.
Okay.
If he doesn't know it. So he has to go proactively do certain things. And what happens is when you have like a huge amount of code in a library like this, and we want to make sure he has done all the right things, it's very hard to actually review it and do a security audit on it. So what we introduced a new feature called transparency. You can mark a whole bunch of code or like entire assembly as transparent. What you're saying at this point is hey, I'm providing a whole bunch of services, but I'm not, I want to run in the context of the app. So if the app is a fully trusted guy, then great, you can call through me, everything will work fine. If it's a sandboxed app, then I'll provide the functionality, but if any demand gets triggered, it goes right past me to you. And if you can satisfy it, you're fine. Otherwise, the demand will fail.
Interesting.
There's a whole bunch of libraries like XML, or Avalon has a whole sort of framework classes that can be marked as transparent. And if it's marked as transparent, we know it's going to be safe because CLR is going to actually provide a whole bunch of safety hooks in there to make sure you don't accidentally satisfy certain demands. Like link demand is a good example. So in this case, if I didn't mark myself as transparent, like this one, right? When this API gets called by, let me pick like another sandbox.cs. So this is like a simple app that I built. So he's trying to, this guy wants to set up a sandbox domain and he wants to execute some code. And this is the untrusted app he's trying to execute. And then this code turns around and says, hey, you know what? I know this transparent class is in the framework. I'm going to call him. And if this sandbox code right now calls his API, he's going to satisfy the link demand, which means an untrusted guy can lure a framework that's exposing partial trust services into satisfying a link demand, which he probably didn't intend to do it, right?
The problem is that, I mean, you satisfy
Yes,
link
I
demand
see.
implicitly. There's, when you do an assert, you have a code access security assert, you actually have to put a line of code to do that. But link demands, you just satisfy, you never see it. That kind of a security issue with 1.0 and 1.1. So with transparency, when you're running transparent code, you no longer satisfy them implicitly. We actually turn them into full demand, so they'll go all the way up the stack through all the code on the stack.
And another example would be like something like this, right? You could have like unverifiable code, right? I do a whole bunch of unsafe things. But normally what happens is like, if this code is used in a full trust scenario, you'd say it's fine. But if like an untrusted guy was able to call this API through some other means, if you didn't mark it as transparent, it's pretty dangerous. If you didn't mark it transparent, you will end up satisfying a skip verification check against yourself, and you will be doing some certain operations. It's probably not.
Especially if he takes a parameter that's the length of a buffer or something like that, maybe he can trick this platform code into a buffer overrun or something.
So if this was a public API that took some length, right, and I turned around and did a stack lock of it, then you could blow the stack, right? And these are dangerous things you could do.
Sure.
But by marking yourself as transparent,
caught in a good static verifiable tool.
Well, this is unverifiable.
Sure.
So
this is unverifiable.
we're
It's a
basically-
verifier will catch it.
Right.
But these things it's very difficult to catch. Like the link demand that I showed you,
Yeah.
it's very hard for you to actually find it.
Yeah.
There are other
We
examples
do,
as
we
well.
do have an FXCOP rule, but again, it's too easy to ignore FXCOP rules. So we wanted to have actual runtime enforcement.
Oh, this is great. I understand. This is all about the runtime.
And we kind of enforce this by this is another test case that shows you how the delegate thing. It's marked as transparent. I'm creating a delegate on top of a method that has a link demand.
Okay.
I mean, people don't realize it, right? Hey, I'm just creating a delegate, and on a method, if the target has a link demand, now this link demand gets satisfied by this code, which is, he didn't really intend to do it. He wanted, he was, because somebody gave him this method, he just wrapped it and created the delegate.
Okay.
What we did is when we see this things as marked as transparent, we actually tell the JIT, when you compile this method, we tell the JIT, say, hey, this method is transparent, and you're trying to create a delegate on top of a method that has a link demand. So we inject this call, saying, hey, do a security check before allowing this code to run.
Okay.
And this converts into figures out what the link demand is, and converts it to a full demand so that your caller needs to satisfy it as well. What this gives is people can build framework libraries with more confidence. They can build a whole bunch of general framework and they can mark themselves Kafka. And unless you explicitly provide certain service, right? I'm saying, hey, I want to assert for this permission. Your transparent code will not be subject to any attacks. It'll be fairly secure and
Fantastic. Now, are you guys going to be talking about this at the PDC?
A little bit. It's kind of mentioned tangentially in some other talks. I'll be there. We have a couple labs that talk about the new security features, so I'll be there talking to people. It's covered a little bit. The talks at the PDC are kind of very high level, mostly focusing on the new Longhorn Vista features like Lua, software licensing. That
Sure.
kind of thing. So we'll cover it a little bit.
there are a couple of MSDN articles coming out as well.
Yeah,
We're
Sean,
gonna talk about those
our
things.
tester, and I both wrote articles for the November security issue of MSDN magazine. Those will be coming out.
I mean, I guess the point I'm trying to make is this has always been the most abstruse part of writing managed code, and it's precisely why no one really uses it. So it's really nice to see that you're doing work, making it easier, more logical, more understandable. The transparency thing,
Yeah,
fantastic.
Easier to do it right.
We would have made transparency the default, but there's a whole bunch of legacy code there, and we can introduce transparency late. So right now, transparency is something you have to opt into.
Sure.
But in the future, we'd say when you write code, you're transparent by default, which means you don't have to worry about code access security in your code,
It's fantastic.
unless you want to opt in.
That's huge. Well, great.
All right, well, thanks, Raja.
Nice to meet you.
Yeah,
Great
nice
job.
to meet you.
Thank you.
Just quickly meet a couple more of our devs here.
See, I noticed he's using Notepad.
Yes,
Right.
Notepad and good old WinDBG. Hey, Tariq. So this is Tariq, dev on our team, and so tell us what you work on, Tariq.
So I've been on this team since the release of 1.0. So I've been through 3 releases now, hopefully 2.0, and I've been working on several pieces of the CLR security model. I own crypto,
since he's the man for crypto.
Yeah, I've seen your name a lot on your user. Always answering the crypto questions.
Yes.
All right. Good to meet you.
So people have me partly to blame about any problem with crypto. And I've worked on code access security, different pieces, click once, debugging zone, several pieces of the code access security engine. Okay.
Yeah. So it's just a quick meeting. Anything else you want to talk about? Or?
Sure. I mean, I can talk about. So I was mostly thinking about talking about two themes that we tried to improve in Whitby. One of them is the hosting ability to participate in security decisions. So we added a feature that's pretty useful actually to hosts for the runtime, which is called Downen Manager, and that feature basically allows a host to participate in the security decisions made by the CAS policy system. In V1, we only had so policy decisions were only controlled by the system admin, who modifies the machine policy and then goes back. And if you wanted to control those decisions, you had to go and modify the machine policy, which you might not have access to because you are not that. Now, if you are a host, you get a chance to customize this behavior, and this is actually pretty useful. And I wanted to give just one example of one useful usage of Downen Manager. So, and that would bring me to the second theme actually that we tried to improve on in Whitby, which is the developer the ease of use of CAS in a developer environment. So Visual Studio in particular added a lot of cool features to better integrate code access security and enable developers to develop semi-trusted applications easily in VS. So right now in VS you could go to the properties of the project and select how to sign the project, for example. That's so you can strong name a project or generate a self-signed key or whatever, and then use it to sign the assembly. That's one thing. The second thing is you could say, okay, this is my assembly, this is my application, I developed it, it works fine. I tested it I ran it and it works fine. Now, if I deploy it from a network share or in an internet environment, the security settings might be different. So in this case, you can actually go to the menu, the security page in the menu, and in the security page you select what kind of permissions you want your app to run with. So you can actually you can choose whether you want to run the app as a click once application or just as a normal application. So you can say I want to just try it with local intranet permissions and see how it works, and then run the app, run F5, and if there is a security exception or whatever, we actually also improved that by giving you more information about the security exception. I can show you a demo actually if you are interested.
Oh, do you have something ready?
Yeah.
Sure, go for it.
One problem, I need your screen switched to 60 hertz.
Okay.
Yeah.
So let's switch the screen.
Hold on just a second. We'll be right.
Good.
So yeah, we're back.
Right.
Much better, no flicker.
Okay.
Very cool.
So let's try this. So I have here a VB application. Okay, that VB application is a very simple application. It just goes and does a demand. Okay, that's all it does.
So it's kind of
It
simulating.
demands file IO permission.
Yeah, simulating opening a file.
Simulating. So if you call file.create, for example, internally it will do file IO permission.demand. So we are doing the same thing here without calling file.create. So here you can go to the projects console application, and then here you have a lot of goodies. One of them is sign in, for example. So if you want to sign the assembly, you can say, okay, sign this assembly. Okay, so here I have a PFX file already, but you can also go and do new and ask VS to generate a self-signed certificate.
Yeah, just basically a random key.
And I can call it whatever. I mean, I can call it tests. And so the main thing about these files is that they are encrypted. So even if they are on your hard drive, they are encrypted with a password. So they're not a key in the clear, like normal strong name keys. So that's a new feature that we added actually to both VS and the strong name signing tool SN to support those kind of files in Whitby. So I can enter a password, any password. Okay, so it generates my test PFX. Now, okay, so
So that
I
just
can
is stored
actually
as part of the
disable.
project.
So first of all, let's disable the security settings, and then let's run the app. It should run to completion. So no security exception. That's cool because we are running from local intranet from my computer.
Sure.
We
So
are
it's running
from
with
my
full
computer.
trust, right?
Yes.
Yep.
So now let's go back to the project page and then go to security and say, okay, enable click once. Actually, it's not always click once. It could be click once, but I mean, mostly we are advising people to use click once if it's a semi-trust application. But it doesn't have to. You can just run the application from network share or whatever, and it will run with restricted permissions.
Sure.
So now, let's say this is a partial trust application, and let's select local intranet. And so that means that the app will run with local intranet. Now let's go and do F5, and the demand. Okay, so we have a first chance exception, which is a security exception. So we have a demand that's failed. Now this is cool because now I have a demand that's failed. I'm a VB developer. I don't know anything about security. Now, what do I do about it? I mean, I am trying to open a file and I'm trying to run my app from a network share, and it's failing. So here there are some tips actually. There are troubleshooting tips. One of them is saying, okay, store application data in isolated storage. So one advice is to go use isolated storage, which is a file system provided specifically for semi-trusted application, where people can basically write files. It's obfuscated so that people can't control
It's been
with.
around for a while.
Yes,
Yes,
in
it's
V1.
been
It has been around for a while, but so that.
Okay.
And it's saying, okay, request for permission of type file IO permission is failing. What does this mean? Let's go to the view detail. So I have the security exception. So I have the whole thing here, and it tells me why it failed. So if I go to the method that failed, for example, it's going to say request for file IO, demanded file IO permission, deny set. That's the deny set, and first permission that failed is a file IO permission.
So it's just giving you a lot more
Yeah, it gives you
information on what
a
actually
whole bunch of
failed, what
information.
the app was granted. Before, this was just kind of guesswork.
Now,
where
I mentioned
you
App Domain
defeat-
Manager in the beginning of this session. So, where does App Domain Manager come into all of this? This is how VS, actually Visual Studio, implements this feature. It implements this feature by implementing App Domain Manager. So if you go, there is a new thing called the VS host in Whitby. So a lot of people have been asking questions about VS. What is VS host?
Sure.
So let's go and look at where the app is generated. So the app is generated over here. So if you go to bin debug, so this is console application.exe. This is my exe. This is the exe that was compiled. And then there is something called vshost.exe. Okay, what is this mysterious vshost.exe? This is the main process that VS is actually launching. So if you look at the processes that are being launched here, so this is what VS actually is launching. It's not launching my application directly when I'm running it. It's basically simulating the app as running from local intranet. So it runs a main exe, which is vshost.exe, and then it sets up an app domain manager. And in this app domain manager, it goes and basically controls what the app grant set is going to be to give it local intranet. And
That's great.
So this kind of
inside
ties
of
in-
that,
yeah.
yeah.
So this is what we were talking about before, where they're actually VS is a host of the runtime, like SQL and that sort of thing, and they're actually using the App Domain Manager and these simple sandboxing APIs to control what the
It's-
app assembly gets in order to do this debug and zone feature.
It's all basically the same theme. If you look at it from that perspective, VS is a host. It launches a host that emulates running the app from semi-trust. Same thing happens in ClickOnce. ClickOnce also does the same thing. It doesn't use an App Domain Manager, but it uses the App Domain Sandboxing API to do the same thing. So that's
great.
that's actually it. So
Cool. Well, thanks, Tariq. It's
Sure.
very interesting. It's kind of
Thank you.
Good stuff.
hitting on our themes again.
Well, the theme is making it easier for developers
Making
to
it
write
easier for
good
developers
code, right?
and
Safe
for-
code.
Yeah, and developers both inside and outside of Microsoft in this case.
So you can
There's
see
a lot
that-
of people using it.
exactly. So Visual Studio uses App Domain Manager, which is a feature that we provided in Whitby to implement a cool feature for our
Absolutely.
customers.
And that's, I mean, you asked about what's the coolest thing about working on the CLR team, and seeing stuff like that. It's seeing people take this and use it in different and interesting ways, and you know, write cool products for our customers.
Totally. Thanks.
Cool. Thanks a lot, Tariq.
Thank you.
Rocks.
Thanks.
Take care, man.
And I think that's about it. We're pretty much out
Oh,
of
that's
time
good.
here.
Yeah,
so.
we're almost out of tape too.
Yeah, cool. So, great.
Well,
Thanks
great.
a lot. It was nice
Thank
to
you,
meet you.
man. Thanks for the
Appreciate
tour.
it. Give a little inside kind of view of what goes on in the security team and the cool stuff coming for Whitby.
Thanks for spending some time
Great.
with us.
Thank you.
Take care.